Hello everyone, it's me Amna and welcome to Amna's Learning Hub. I hope you all are fine and finding my videos helpful. Today we are going to start a very important chapter which is also very confusing for the people. So the chapter which we are going to start is organic chemistry. One of the major portion of every paper, whether it will be the paper of metric, it will be the paper of O levels, it will be the paper of A levels, or it will be the paper of FSC part 2, right? So organic chemistry is the, you can say, backbone of general chemistry. If we talk about the subject of intermediate or secondary education, so in that level organic chemistry is the basic thing. So what is organic chemistry? This is the era in which we heard that everyone wants everything organic. We want organic food, we want organic skin products, we want organic, so many organic things. We want organic paints, we want organic furniture. The organic, whenever the word organic comes, so the thing that comes in our mind is which is good for health and which is natural and which is extracting from plants and animals, right? So now we are diving into organic chemistry, that what organic chemistry basically is, how we can identify the particular thing, whether it is organic or not organic. So first very important thing about organic chemistry is the basic idea. The initial previous scientists, they thought that anything which is extracted from plants and animals, that means anything which is extracting from living things is called organic. And to study those things in detail chemically is known as organic chemistry, extracted from plants and animals, right? But later on they found out that this is not the only thing. This is not the thing that only plants and animals extracted things are organic. Organic things can also be extracted or synthesized by humans, right? So there are two concepts about this. First, the previous concept was that the things which only extracted from plants and animals are known as organic ones. But now the men can also synthesize things in laboratory, which is called organic. Now the latest definition is anything which has carbon and hydrogen, compulsory carbon and hydrogen, and then it has oxygen, it has sulfur, it has nitrogen. So any compound which has carbon and hydrogens compulsory, and then has oxygen, then has sulfur, then has nitrogen, they are known as organic compounds. And to study the organic compounds is known as organic chemistry. So the modern definition of organic chemistry is any compound in which the basic skeleton or the basic chain is of carbon and hydrogen, and in which there can be oxygen, there can be sulfur, there can be nitrogen, and there can be some other elements as well. These the compounds are known as organic compounds, and the study is known as organic chemistry. In organic chemistry, we have a very important term which is called hydrocarbon. Today's lecture is basically the introduction of organic chemistry. We must know all the basic things of organic chemistry so that it will be easy for us to understand the deep concepts of organic chemistry. So hydrochemistry, hydrocarbons. So whenever the word hydrocarbon comes, that means it is composed of hydrogen and carbon. So any compound which has only carbon and hydrogen is known as hydrocarbon. For example, we have an example. Simplest example is methane. It has one carbon and it has 4 hydrogens. So this is known as hydrocarbon. So all alkenes, and all alkynes are known as hydrocarbons. Clear? All alkanes, all alkenes and all alkynes are known as hydrocarbons because they only consist of carbon and hydrogen and they have covalent bonding in them. Clear? So, overview of this. First of all, I told you that modern definition of organic chemistry is any compound which has carbon and hydrogen compulsory, and it can have oxygen, nitrogen, sulfur and other elements is known as organic compound, and study of organic compound is known as organic chemistry. After that, I told you about hydrocarbons, that compounds which have carbon and hydrogen only are known as hydrocarbons, and the major example of hydrocarbon is alkanes, alkenes and alkynes. Next thing about organic chemistry will be some important prefixes. While dealing with organic compounds, we must know a few prefixes. Prefixes. Pre means which comes before the word. And we also have some suffix, which means something which comes after the word or part of the word which comes in the end. Prefixes mean any word or part of the word which comes initially, and suffix means any word or the part of word which comes after the in the end of the word. So in chemistry we have some prefixes, which is I'm going to tell you about 10 basic prefixes, because at this level of O levels or metric we usually use these prefixes. So first one is meth. Meth means 1. Second is eth. That means 2. Third is prop. That is 3. Fourth one is but. That is 4. Then pent. That means 5. Then hex. That means 6. Then hept. That means 7. Then we come with oct, 8. Non, 9. And dec is 10. So these prefixes are very, very, very important, because if you remember these prefixes, it will be very easy for you to understand the whole chemistry of organic compounds, because these are the basic, you can say, this is the counting of organic chemistry. Meth 1, eth 2, prop 3, but 4, pent 5, hex 6, hept 7, oct 8, non 9 and dec is 10. These are some prefixes that we will use for all the organic compounds, for all the functional groups, for everything. Now what is functional group? I am going to tell you, and what are the suffix? I will tell you about those as well. So after knowing all these prefixes, please memorize these prefixes if you want to make your organic chemistry easy. Otherwise it will be very difficult for you to understand this. Okay. After these counting thing, we are going to learn about functional group. Okay, functional group. Group, by word group, you will understand that there is some group of elements. We have some elements, and functional is representing kind of family. So there are a group of elements, or there are bonds, or there is something which is the identity of particular organic compound, or the list of organic compound, and which is showing the whole family, is known as functional group of that particular organic compound. For example, if we talk about the family name, any family name, we can say Chaudhry's. So Chaudhry's means this one word is the functional group, and it is representing the whole family of Chaudhry's. Same is the case with the functional group. When we have a family of organic compound, that will be represented with the functional group, with the group of elements, and that is called functional group. For example, at this level, we are dealing with the functional groups called alkane, alkene, alkyne, then we have alcohols, then we have carboxylic acid, and then we have esters. So these are some families, and they have some functional groups in them which will represent the whole family. For example, if I talk about alkane, so alkane will have one covalent bond throughout the compound. It will have only one covalent bond throughout the compounds of this family. Then if I talk about alkene, it will have two functional groups in the whole family. Then if I talk about alkynes, it is representing three functional groups throughout, three covalent bonds. Alkane, one covalent bond, alkene, two covalent bonds, and alkynes, three covalent bonds. Then we have alcohols. Alcohol means any compound will have OH in the end. This is the functional group. Any alcohol will have OH in the compound is known as alcohol. Any compound, anywhere, wherever you see any OH attached with the compound, that is representing the alcohol family. After that, we have carboxylic acids. Carboxylic acids will have C, double bond with O, and then OH. Whenever you observe any C double bond with OH, then it is a representation of carboxylic acid. It can also be represented as COOH. That means the whole compound can be anything, but if you observe any COOH, that means this is the family of carboxylic acid. Ester, whenever carboxylic acid is combining with alcohol, so this is known as ester. This is basically the linkage. When I will explain you about carboxylic acid and alcohol, I will explain you ester in detail, because ester is basically the linkage between carboxylic acid and alcohol. When carboxylic acid and alcohol combine together, they forms a compound which is called ester, and ester is the linkage between the carboxylic acid and alcohol. So I will explain you this in later. So for this level, at your level, we will learn about alkane, we will learn about alkene, alkyne, a bit about alkyne, then alcohols and carboxylic acid. So basically at this level, the things that we will explain in detail, or we will learn in detail, are alkanes, alkenes, alcohols and carboxylic acid. I will give you a brief concept about alkyne as well. Okay, after knowing these, now I am going to write these names with another marker so that it will be clear to you about suffix that I told you. This ane, this een, this ein, and then ol, and then for carboxylic acid we have suffix oic, acid. Okay, now this must be clear to you that whenever we will have any alkane, for example, it is ethane or it is propane or it is pentane. So you will see this ane is representing this particular compound is of alkanes. This ane again representing the particular compound is of alkane, and then this ane is representing the particular compound is of alkane, and these are the suffix which will come in every compound. The other thing to observe is eth. Now eth means 2. 2 means it will have 2 carbons in it. The counting meth, eth, prob, prob, but, pent, hex, hept, oct, non, dec. All of these numbers are representing us the number of carbons in that particular compound. Now eth means 2, so it will have 2 carbons. Each carbon is connected with the other one with single bond. I told you that all of the alkanes will have single bonds. So carbon is attaching with the carbon with the single bond. Now one more thing to memorize is every carbon will form 4 bonds. Always every carbon will form 4 bonds. Whenever you make any organic compound, you have to complete the 4 bonds of carbon. So now here carbon is making 1 bond with the carbon. Now how many other bonds carbon can make? 3, because total 4 bonds can be formed by carbon. So all of these 3 bonds will be formed with the carbon. Now both of the carbons will have 4 bonds, like 1, 2, 3 and 4, 1, 2, 3 and 4. In alkanes, after forming a chain of carbon, all of the vacancies will be filled with hydrogens. Everything will be filled with hydrogens. So when we can make a compound, after satisfying the bonds of carbon, we will attach hydrogens with it. This is called ethane. Now eth means 2, ane means this is alkane, which is representing that it will form a single bond, and then the whole name is ethane. That means 2 carbons, and 2 carbons will form 4 bonds. Each carbon will form 4 bonds, and all the bonds will be single. Clear at this point? Same is the case with prop. Now prop, if you memorize the counting, prop means 3. So again we will draw 3 carbons, 1, 2 and 3. Each carbon will form 4 bonds. This carbon has 1 bond, 2, 3, 4. 1, 2, 3, 4. This carbon has 1, 2 and 2 spaces, 1, 2, 3 and 4. This carbon has 1 bond, so 3 more will be formed. So all of the bonds will be satisfied with hydrogen. So this is called propane, and it has all single bonds in it. Prop means 3, ane means this is alkane, and it will have all the single bonds. That is why the formula is this. Clear? Now we are done with alkane. We discussed about the prefix, we discussed about the suffix, we discussed about the functional group of alkane. Let's move towards the next compound. Now we have alkenes. Alkenes means 2 carbon. Again I am writing an example. Eth means 2, and then we have ene means double bond. Ethene, 2 carbons. Ene means double bond, 2 bonds, and every carbon can form 4 bonds. So this carbon is already formed 2 bonds. So 2 more bonds will be formed. Here again this carbon is making 2 bonds. 2 other bonds will be these. Now each carbon is making 4 bonds. 1, 2, 3 and 4, 1, 2, 3 and 4, and every bond will be satisfied or connected with the hydrogen. So this is ethene. Carbon, 2 carbons, eth means 2 carbons, ene means double bond, and every carbon will make 4 bonds. So all of these bonds will be satisfied of carbon and 2 bonds are formed, which is showing us that this particular compound is alkene. Again, prefix and suffix are satisfied, and with the suffix we can find out the functional group. With this suffix is basically the identity of the functional group. I hope it is clear to you. Now, next example will be alkyne. Okay, eth again means 2, ine again means triple bond. So we will make 2 carbons. Both of the carbons will have triple bond, and carbon can make only 4 bonds. So 1 hydrogen and 1 hydrogen will be attached. This is ethyne. Clear? So this is how we can identify alkanes, alkenes, alkynes, and we can differentiate them, and with the prefixes we can find out how many number of carbons are particularly present in it. I hope till here the concept is clear. Next is of alcohol. Alcohol, it will have suffix of ol. Whenever the word ol comes, that means this particular thing is alcohol. Now, ethanol. Eth means 2, ol means it must have an OH, and each carbon can form 4 bonds. Again, C and C, they are making single bond with each other. Then it will form 1, 2, 3, 4, 1, 2, 3, 4. Each carbon can form 4 bonds. So 1, 2, 3 and 4, 4 bonds of one carbon. 1, 2, 3 and 4, 4 bonds of other carbon. So all of the bonds will have hydrogen 1, 2, 3, 4, 5. But one bond will be of OH. One bond will have OH. That means now this particular compound is ethanol. This is alcohol. Now if I write the condensed formula, like this is the representation of the whole bonds. Now if I condense this, so this particular carbon, it has 3 hydrogens, 1, 2, 3, 1, 2, 3. So CH3, right? Now this carbon C, 1 and 2 hydrogens, CH2, and now this one we will represent it with the OH, CH3, CH2, OH. This is ethanol. This is how we represent the compounds by their functional groups, and prefixes tells us that how many number of carbons will be present in that. At this level, last but not the least, is carboxylic acid. Again, we will use prefixes and suffix. The compound that we will discuss will be ethanoic acid. Ethanoic acid. If you can see, oic acid is the suffix which will represent the carboxylic group, which will represent the functional group of carboxylic acid. And eth means it will have 2 carbons. So whenever the compound will have 2 carbons in it, so that is ethanoic acid. The total 2 carbons must be in it. Total 2 carbons. Clear? So C and C, each carbon can form 4 bonds. So CH3, and then I told you that this is the functional group COOH. So carbon is making 2 bonds with oxygen and 1 bond with other OH, and here it will have all the bonds with hydrogen. So basically CH3 COOH is known as ethanoic acid because it has 2 carbons, 1 and 2. So this is the carboxylic acid. So to summarize this whole lecture of introduction of organic chemistry, I explained you about organic chemistry, that what is organic chemistry. Then I told you about hydrocarbons, that when hydrogen and carbons come, when compound has only hydrogen and carbon, this is called hydrocarbon. Then I told you about functional group, that this is the particular group of elements which will represent the family of that particular organic compound. So I gave you 4 or 5 examples of organic compounds, functional groups: alkane, alkene, alkyne, then alcohols, carboxylic acids, and ester is the linkage, which I will explain you after discussing about carboxylic acids and alcohols. For alkane we have single bond, for alkene we have double bond, and for alkyne we have triple bond. For alcohol we have OH, and for carboxylic acid we have COOH. This is the whole story of the functional groups. I hope this is clear to you all. Now I am going to give you some I'm giving you some names, and you have to draw the structural formula of those particular compounds and share the pictures on with me on Instagram, or you can message me on YouTube, or you can comment there by the picture, with the picture, so that this particular thing will be clear to you all. If these basics will be clear to you, then it will be very easy for you to learn more organic chemistry and deep concepts of organic chemistry, and how the reactions happen and how different things happen in it. So I hope this was helpful for you. Now I am going to write some practice questions for you. You have to draw the functional groups. Okay. Draw structural formula of following compounds. Number 1, propane. Number 2, butene. Number 3, ethane. Number 4, butanol. Number 5, pentanoic acid. Number 6, propanol. Number 7, hexene. Number 8, heptane. Number 9, octane. And number 10 will be propanoic acid. I hope the lecture was helpful for you people, and practice these following formulas, and draw the structures and send me the pictures on Instagram, and you can also send me the pictures on YouTube. So stay tuned, stay connected, and I hope organic chemistry will be very easy for you all. Thank you so much for watching my videos. I will be waiting for the positive comments or the feedback from you all, so that I can improve my teaching skills. Thank you so much. Allah Hafiz.